yeah, like Venki, you know me from having taught you on the CDT course, so you know a little bit about what I've done. But yeah, just to give you a bit more, so I do numerical hydrodynamic modelling of wave energy converters and particularly arrays. As we did in the class, we looked at frequency domain modelling, but here I go on to study time domain modelling, which you have to do in order to account for nonlinear external forces. So we developed under the SuperGen program a time domain array model. So this takes into account when you have arrays of devices, you have the diffracted and radiated waves between devices, so it takes into account all the interactions between these devices. So here we have some flaps moving and some buoys. You might wonder what the colour map on the surface is. That is showing the disturbance to the surface caused by the motion and diffraction of the of the devices. So where it's red means it's above the undisturbed free surface, where it's blue it's below. Also, together with some colleagues, we've combined that hydrodynamic array model with models of the generator, models of the grid, so we have a full wave-to-wire model, and that's a bidirectional wave-to-wire model in that we can also run it the other way around. So if we have a network event, we can see what effect that network event has back on the buoys and on the sea. Yep. Okay. The other thing that David briefly mentioned was this Polywick project, which David leads and which I work on. And just to give you a very quick, what is a Polywick project? It's using elastomers. So basically your power takeoff now becomes this elastomer, which is just a rubber material. You put electrodes on either side, top and bottom of it. When it's fully stretched, you charge those electrodes. As it relaxes, pulls the electrodes apart, the voltage increases and you discharge and you can get more power out. So this project we're working on, and this is just some tests we did in FlowWave just about a month ago, where we have a OWC, and instead of a turbine on it, we have one of these dielectric elastomer generators. And we actually generated 2 watts there, which doesn't sound much, but actually when you scale that up to full power, it's quite a considerable amount of power. Also, just to go through, I have some current PhD students working on a number of things. Anna's looking at geometry optimization of WEX to maximise performance and minimise cost. I've got a number of IB course students as well looking at control. Also, some guys looking at the Albertern device in particular. In the Albertern device, I don't know if you know of it, you have closed kinematic loops between devices, so that makes it, you have to model these multi-body systems, and having closed loops makes it more complicated. And another guy, Anthony, is looking at very large arrays of these devices. So yeah, that's me.
This production is brought to you by the University of Edinburgh.